Hello everyone, welcome to the stream. I'm glad to have you all here. My name is William Moore. I'm a product manager here at MathWorks. I work on the report generators, which we're going to be talking about today. Thank you for all for joining us for report generation for model-based systems engineering. I think we have a lot of really interesting topics, whether or not you want to hear about reports or model-based systems engineering, or you're just kind of here for fun, whatever works. So I also work on the aerospace products here at MathWorks. Prior to joining MathWorks, I have a background in the aerospace industry. I worked on engine control software as well as flight control software, model verification and validation. Also definitely used a lot of MathWorks products and including and had interest in doing software for DO certification, which I'll talk a little bit more about when we get to report generation. Joining me is Andrew here, and Andrew, if you want to introduce yourself.
Absolutely. Hi everyone, my name is Andrew Grabowski, and I'm the product manager for our tools System Composer and SimEvents, both systems engineering tools. A little bit about my background is I come from our application engineering group, where I assisted our aerospace customers similarly in systems engineering, did a lot of DO-178, code generation, verification, validation, as well as a lot of cloud-based workflows. So happy to be here. Really excited to talk to you all about report generation for systems engineering today.
Awesome, Andrew. Yeah, and as just a little bit very high level, so as I mentioned, this conversation we're going to have today, it's going to kind of come in two parts. We're going to start by really focusing on the model-based systems engineering. Andrew's going to take point on that, have that conversation. That's going to be the first half, and then the second half, I'm going to go over more on the report generation side, and then also crucially talk about the integration together. Three basic things we're going to be covering today. We're going to, as I mentioned, when we're talking about model-based systems engineering, we're going to look at architecture reports and how to create that. We're also going to be looking how to generate web views. And then finally, we're going to be covering how to customize, basics on how to customize reports using the various APIs associated with that. So I think that's all the general overview. Now, I've got a very important help I would ask of you if you're here in the chat. If you can please just ask questions throughout. Really makes this much more of a conversation, much more dynamic. It avoids us just talking sort of at the presentation. So please just ask questions throughout, and appreciate you, everyone here. So Andrew, if you want to get started.
Absolutely. Thank you, William. As William said, please ask questions throughout. We'll see them pop up, and we could answer them throughout the presentation, or we may take some time throughout working in the tools or going through the presentation to answer those as they come in. So really, feel free to ask us questions on anything. We have a somewhat diverse background. We're going to be diving into an automotive example today as well. So really, hopefully, have something of interest for everyone from beginners in MATLAB, Simulink, and System Composer and Report Gen, all the way to the experts. And feel free to ask anything regarding the MathWorks tools. So let's first jump into what is system engineering, and particularly what is system engineering and model-based system engineering with the MathWorks tools, right? So we're going to start in the PowerPoint, but we're going to go over to the tools and really focus on developing a really innate understanding of how the tools work in this space. So to start in systems engineering, we usually start with stakeholder needs. It's a customer or a teacher or someone asking you, what do you want to start building? And they're going to tell you, I want to start building a car, I want to start building a plane, a medical device system, maybe an insulin pump, anything along those lines. And that's going to feed directly into your requirements and your use cases, right? Starting from the top, this is then going to lead into your architecture. This could be a back of a napkin sketch of what is going to start accomplishing those requirements. If it's an airplane, you know that you're going to need some wings, some controllers, possibly some fuselage to actually maintain the passengers in a plane. You could bake that into the structural, and then you could start doing some high-level behavioral models as well, saying what does this plane need to accomplish? And this is going to be, as it says, a highly iterative process where you're going to be communicating with the people on your team and even outside your team as to what this system needs to do. And this is really helpful because it's going to help you find errors earlier on in your process than building out the plane and then all of a sudden getting your customers' needs and seeing, hey, we built the wrong thing. And this is going to bake into a validation type workflow. So some of the other interesting things you could do at the architectural layer is start building out the system characteristics. You could see on this left-hand side, I'll actually show you, map this out. You could see, start baking in size, weight, power, performance, cost, reliability, all sorts of metadata that can be attached to your architecture. You could use some sort of analysis engine that we'll get to in a bit and understand these architectures and behaviors a little bit better on. Also, we're going to be discussing how can you just start communicating these architectures and viewpoints with a lot of your stakeholders. How do you make these architectures useful, right? How do you show useful, things like what's the latency throughout this entire system? How do you show, oh, here's the data flow. For instance, if a pilot presses, hey, I want to stop, or I want to control this aileron, how does that data flow move throughout your entire system, right? It's examples like this, and again, trying to catch those errors early on in the process is a main tenet of model-based design and model-based systems engineering. The next thing I'll touch on is how do you start connecting to all the goodness that you have in the MathWorks toolset, right? In the system engineering space, how do you start connecting to model-based design in Simulink? Or if you're not familiar with Simulink, it's our dynamic block-based language where you could start building out simulations. You could start exploring how your system is actually going to work. And we have all sorts of workflows where you could generate code from these models, where you could create linkages from requirements down to the models. You can do visualizations, which William's very familiar with, in terms of showing them in Unreal Engine, things like that. So again, a highly collaborative work use case where you're always feeding these case studies into your requirements and really trying to understand your system at a much more ideal level. And throughout this, you want to be able to be generating reports. You want to be able to generate your artifacts, as opposed to, in a document-centric approach, have the documents be the source of truth. We want to centralize all our data together, bring it all together, so that when we need a report, we're able to just export it instead of having to manually write out, spend hours, days writing out reports so we could send them to our stakeholders. So that's the spiel on systems engineering. Some common user challenges around this space are at the architectural level, things are hard to use. There's a steep learning curve in terms of building out architecture models and having a systems engineering type of thinking pattern. Also being able to do multiple viewpoints, again, is a very similar use case. A lot of architecture tools, it's sometimes not very easy to analyze nor execute. Of course, connecting to the MathWorks tools, we really had an emphasis on this ability. And then as well, between the architecture and model-based design, being able to connect your architecture, so your model-based system engineering work, with your model-based design work. And then, of course, being able to respond to change, seeing how, when a requirement change or some part of your architecture design changes, making sure that you're able to immediately make that change in the models and see how it propagates throughout the rest of your system. And this will save a lot of time. All right? So what does the actual tool set look like for this unified environment for model-based system engineering and model-based design? It starts with our tool system composer, where you can start building out your architectures. You could connect to MATLAB, start running analyses that we won't touch on too much today, but from here you could generate reports. You could do a lot of interesting things as well. You could create views, which we'll actually see quite a few examples of, and then also create a bridge, which we'll be taking a long look at today. But of course, being able to create what is called in the industry a digital thread throughout all these different artifacts, so that you could navigate between all the different artifacts you have in your model-based environment. You could generate reports from all these artifacts. You could analyze, run scripts and things like that over this data. Really just wanting to connect everything together and be able to generate the reports. And that's what we're going to focus on today. So let's actually jump into the tool. So again, please remember, ask us as many questions as you want. I know there's going to be a lot of topics covered today. So if you're overwhelmed, we're here. We're here to help. Ask questions. We could slow down, cover a topic in a little bit more depth. We also have amazing documentation that you could take a look at, and we could even direct you to some of that. All right. Thanks, everyone. So the first thing I want to step into is actually the requirements, because right, if we go back to the graphic I was just showing, we started off with requirements. And these really try to tell the story of what your system wants to accomplish. Here, we're going to be building out an electric vehicle. It's a very simple example, but I think it really shows the mechanics of the tools and allows you to think about how you could start applying these tools to your own development of your system. So in today's example, we have this electric vehicle. You can see we have a couple different requirement sets here where we've broken them into functional, logical, and physical requirements. I'm going to stay focused in the logical requirement section, but there are parallel development processes that we're not necessarily showing today where we're building out functional and the physical representations of the system as well.
Andrew, could you give a little bit more, I guess, detail on the difference between the functional and logical architectures?
Absolutely. So there's a lot of different approaches to doing system engineering. Great question, William.
Yeah.
So at MathWorks, you can actually see in some of our documentation, the functional tries to address the what. What do you need? What type of functions does your system need to be successful according to your requirements, right? Addressing the what, and that's how I try to break it down. And actually, I think I have a slide. Yeah, actually, let's show this. Yeah, spur of the moment. This is a live stream, so who knows what's going to happen.
Yeah.
So functional addresses the what, right? What functions are needed for that system to be successful? The logical architecture then encapsulates all those what's, the functions, into logical groupings. And you'll see that example today. And although this does look like it's a unidirectional path through your design of your system, remember, all these arrows are actually bidirectional. And the reason I don't change the slide is because I really want to call attention to this point, is that when you're building model-based design and model-based system engineering, everything's connected and everything could feed back to the thing that it came from, right? And so the logical is addressing the who. And then this could also inform the where. Where is these logical groupings of functions going to sit on your actual system? You could think of, let's say you have a system on chip, which is like a CPU and an FPGA. This might be a little bit more of an in-depth example, but you're trying to figure out where you want your algorithm. Let's say you have some algorithm described in your logical architecture. You want to see where your algorithm sits on the physical architecture. And so you could create allocations. This is a concept in System Composer and system engineering of allocating certain parts of this algorithm to certain parts, whether it's the CPU, the FPGA, and you could actually do trade studies in this space. These are some examples that we have in our documentation where, let's say you put some part of your algorithm on the CPU and some part of your algorithm on the FPGA, you can see what are the timing, the memory constraints, how is it going to run there, and then you could iterate and permutate the combination of the allocations to see what's going to work best. And so that's maybe a little bit more of an in-depth example on the physical architecture. But yeah, that's the typical breakdown.
Okay, cool. And then just as a connecting it sort of to my work, one thing I was thinking about, so you mentioned sort of the digital thread with these being connected. So say, for instance, based on my background, I'm working on an engine and then the airframer goes and says, actually, we have a change within the electrical system and some of the connections are going to change. So we have new functional requirements. Would this be able to help with something like that?
Absolutely. Absolutely. So that really, again, gets to the digital thread, right? Digital thread aims to help with navigation, also analysis, and also lifecycle analysis that we'll take a look at a little bit later. But when you make the change, we actually have tools for this, such as the traceability diagram in the requirements toolbox, where you can make a change in one requirement and see how it's connected to other requirements throughout your design, as well as how it connects to design elements and system engineering elements, such as you might have to change this block, or this block name changes, or functionally, this Simulink block has changed, or even connecting to MATLAB code and things like that. So yes, exactly.
Yeah, no, that makes sense. And then that's certainly helpful, because I know I've certainly, especially with my previous work, I've spent a lot of time on regression and figuring out what changes have made and what are the implications and stuff of that nature.
Exactly. It could take a lot of time. So that's our goal, is to help make those processes a little bit easier. Yeah. So let's take a look again at the model. So here we got to the requirements. We broke it into logical, functional, and physical. But of course, there's a lot of different approaches to system engineering. This is not the prescription to follow this certain methodology, but our tools really aim to help a wide variety of system engineering methodologies. So we have this requirement, again, showing the digital thread. We just say the vehicle shall have a battery charging station to recharge the vehicle when not in use. A very high level requirement, but we're at the system engineering space. We're keeping this relatively high level. And to show you the start of our digital thread, you can see in the bottom right-hand corner, we're going to have something called links. And this is going to be something you see throughout a lot of the MathWorks tools, is that we could create connections between these artifacts. And so this is a model that's already been somewhat built up. And so I have an existing link. So if I just click this, that's going to take me directly to my model. And I want to call out that this is System Composer. System Composer is our model-based system engineering tool where it helps with software and system architecting. And I'll say that throughout this presentation. It's both for software and system architecting, where you could do a lot of things, and that you'll see just a little bit of what you could do with the tool today. But feel free to reach out to MathWorks if you're interested in diving in a little bit more as well. So this is System Composer. You're going to see, I'm actually going to close this notes section. Let's see, it looks a little bit like Simulink, where you have blocks and signals, right? You have input ports, you have things like that. And that's really was one of our driving factors in building this tool. We wanted a system engineering tool that would be easy to use, would be intuitive for the MathWorks users, and that you could get going on system engineering immediately. So let's talk a little bit about what this example is showing. And again, I like to show the requirements underneath the models.
I was going to say, I thought you were going to say underneath the hood because we're working on a car.
Yeah, well, yeah, exactly. All right. Yeah, underneath the hood. Right, telling the story. These requirements are telling the story. And the way we built out that connection is, see here, I click on data concentrators. If I look at the model, it immediately shows me the requirement that is specifying those blocks. We see here, we have under the power management system, we have the battery data concentrator. It's also connected to the driving data concentrator. And the way we made those connections, it's actually very easy. I'm just going to do a simple example. I just click on that requirement and drag it onto that component. And that creates that link. I could click in this corner, and there we see health monitoring system and battery charging system. And we could show these requirements if we want. And so that's how we're going to start telling the story and connecting it to our architecture. And so you could think of this architecture model as a back of a napkin sketch. You could think about it as, if you're starting to build out a system, what are the key components, what are the key ideas that you need in this system, right? And again, this is logical, but you could do this for a million different types of methodologies trying to address this. So let's talk about the tool a little bit. So System Composer, yeah, has the ability to link to requirements. You could, I'm not going to focus too much on this today, but you could generate reports directly from these requirements. You could go to the requirements editor, and they have the share button where you click export and say generate reports, and it's going to open up a nice little UI that can help you customize the report a little bit. You're going to, in System Composer, have the ability to just create components very easily. Back of the napkin sketch, we'll say this is a power storage system, and that's how you start interacting with this, right? And you could create connections, connect them to other things. I'm not going to do too much today customizing it, but feel free to look in the documentation. There's a lot of great examples. Some other things I like to point out is, let me open up our property inspector, where you can access it by going here. You could attach metadata, and that's where a lot of this coloring is coming from, where we've created a thing in the system engineering space that's called a stereotype, where you're able to attach metadata to these components. You can see here, I've attached who's the owner of this power distribution system. It's Andrew, that's me. Who's the owner of this battery charging system? That's Josh. Josh was actually one of the original authors of this demo. Marco as well, he also helped with this demo. So who are the individuals responsible for each one of these components? These are things you could start attaching here. And you could get pretty advanced with this level of metadata capture. You could start throwing in the power, costing, sizing, all that. and start running analysis there. And again, feel free to ask questions along the way. I know we're going through a lot here, but be happy to stop. There's a lot of other architectures. We mentioned on the behavioral side, how do you start modeling behavioral models at the architectural level? We have things like sequence diagrams, where if you see this diagram, where each one of these, what's called a lifeline, where it's the battery data concentrator, the battery charging, power distribution, you can see how we want each of these to pass data across each other. And you can see here, coming from the outside of the system, we're passing charger-connected data. And then we could create some relatively complex scenarios where if, we could say things like, if the charger connected is true, we're going to go through this sort of behavior. And I'm not going to dive too much into this today because I really want to get to the report generation side. But you could start creating these scenarios, and you can actually simulate these once you start connecting Simulink underneath the hood into under System Composer. And we'll talk a little bit more about this.
So Andrew, just to pause for a second, we do have a question. We're wondering, I think this might be the previous screen, but is power management a component or is it a partition like in enterprise architecture?
Yeah, great question. So we actually took a design decision here. We took some liberties here. So power management is actually just an annotation. We just want to make it a little bit more intuitive grouping of all these different components in the power management section. But we could actually formalize this and say, hey, we want to throw these all under one component called power management. The reason we didn't was just a design decision. We wanted to make it very easy for everyone to see the power management, driving management, and motor control system together. But you absolutely could group that all under one component if you wanted to.
Yeah, so to, I guess, expand a little bit, basically there's capabilities to do stuff on just the visual side and then functionally also implement stuff.
Absolutely, and that's, I guess, the really important part about system engineering. Sometimes you want to have a little more flexibility with your tool to start expressing your ideas a little bit more clearly that may not totally be represented on the functional side. And that's what we're going to talk about next. In terms of, can I expect? So we got a question, another one. Yeah, can I expect can I export the stereotypes into RecIFs? Great question. So you could export requirements to RecIF. That's a requirements interchange format. It's specified by industry that allows the interchange of requirements to a lot of different tools. And yes, Requirements Toolbox supports that. You could actually stereotype your requirements to add additional metadata to those requirements, and yeah, you could export those to RecIF. Great question. Yes, and that's a very common use case. The workflow would look very similar to what you're seeing here, just maybe starting in a different tool or ending in a different tool. Yep. And so one thing I do want to call out, right, is so we built out our system architecture in System Composer. And I think one of the more powerful capabilities of this tool is that it was designed, right, to be intuitive, to be scalable, but also to directly connect to Simulink. And so I stepped into this power distribution system. I'll actually step into this battery charging system because it's a little bit more interesting, I believe. And you're going to see in this top right-hand corner the Simulink logo. And really all this is trying to tell you is that underneath this component is a Simulink model directly linked underneath the hood. Underneath the hood again.
Yeah.
Had to throw William a bone there.
Yeah, I appreciate it.
Yep. And so what this means is I could just double click into battery charging system and there exists Simulink, right? This is optional, right? We don't have to connect all these components to Simulink. We could just use System Composer as a system architecting tool. But we have the capability when along our product design lifecycle that at some point we want to formalize the design in Simulink, we could connect it. And so what this enables us to do is we could start doing things like simulating these models, right? If we have Simulink under hood, it's simulatable. We could generate code from these models. And we could do a lot of the things that we're familiar with model-based design. And just because I want to make sure we have enough time to get to report generation, I'm not going to dive into too much, but there's also concepts of things like test harnesses where you could isolate these models and test them in isolation and then slowly build up that testing infrastructure all the way up to the system level. But I do want to show you one quick example of just running these models in simulation. So here we have an entire EV logical architecture, and you're going to see that we're actually calling that logical architecture model from directly underneath this model. And if you're familiar with reference blocks and reference models, this is a very similar concept, being able to reuse these models across multiple different models. So there we have that logical architecture of the vehicle control system. We have our vehicle, which is modeled in Simulink and Simscape, our physical modeling language, which is very helpful. And then we have this stand-in driver or an actor, where it's going to be passing in stimulus to our vehicle saying, how fast should we go? How slow should we go? We won't go, I'll say it again, under the hood on that one. My creativity is going. I gotta say it multiple times.
It's all good. I mean, the only thing I would love is if we could have and I could try and also help the numbers. We had a little counter.
I know.
Just said under the hood.
We're at 3 right now.
Yeah.
We're at 3. So what I'm going to do right now is actually click run. You may be familiar with what run means in Simulink, but what does it mean in System Poster? It really means the same thing. We're going to be compiling and simulating all the models underneath the hood, underneath these System Composer blocks, right? Again, we're just taking an intelligent approach to being able to simulate this model. It's not going to simulate if you don't have any design underneath the blocks. I'm trying to avoid to say it now. But if you're able to simulate, it's going to let you. And so you can actually see in things like the Simulation Data Inspector some interesting results. So I'm going to actually just close this really quick, and let's just take a look at our velocity, for instance. So we could see, we do a really quick drive up to 60 miles an hour. We're seeing how the velocity changes. We're going to maybe take a look at the system voltage, things like braking pressure, brake command, and what's really important here, we could take photographs of this. We could pass this over to our reports. There's actually a button once it's done simulating that I could automatically generate reports from this data that I've accumulated through my simulation. You could also build out large testing infrastructures. That's what a lot of my background is. Start building out to continuous integration type workflows if you're familiar with Jenkins, or you have remote repositories, or if you're working with large teams in a model-based paradigm. So I think it's really helpful to see some of this and see how the simulation works. See here, you could start taking snapshots. You could build out a report. There's a lot of customization that William will be covering here. So the last thing I want to show you is building out the report. So there's a lot of different reports that we could build out from here, and pretty much every single step along this entire tool chain, you could build reports out from. But let's build out something I like to call, well, it actually is called the web view. And so in this logical architecture, you're going to see underneath the Save button, we could click the web view. And there's a lot of different options here. Our report generator tool likes to make this really easy for you. But what the web view is, and let's just go through the options quickly. You're able to export this to HTML. You're able to export the model. You could export the reference models, the behavioral components. You could see I could even include the notes. That was the quick little sidebar that I was able to add additional metadata about what is this model trying to explain. I could also include the requirements view. And so if I click export, that's just going to export all that data out to a HTML viewable web view so I could view it in my browser, right? And so as that is generating, there is a question in the chat. So do the links connect with all the downstream linkages in all directions? Yeah, that's a great question. And that's exactly what things like the traceability diagram help you accomplish. So for instance, if you have a top level link, we'll just say, in this example, it's the car link, and then we have a subsystem that links down to a subsystem requirement, and then like a subsystem requirement. You'd be able to navigate through all those links and figure out what was the top level link, what was the bottom level link, and it's a nice little view that you could follow those linkages all the way across. So yes, do the links connect with all downstream linkages? Yes, and you could also, what I think is really nice, is export like a graph-based representation of those linkages as well, and do some interesting analysis if you're interested in diving into the weeds there. So getting back to the web view, we saw the web view actually generated. Here, I'm going to interact with it just like I did on the System Composer side. I could click on these blocks. For instance, here we see the same coloring on battery charging system, power distribution system. We see our stereotype value, still Andrew. Nothing's changed there. Oh, sorry, I clicked the wrong button. You could navigate this, you could dive into it. I think this is really helpful. Let's take a look at the same one. So battery charging system. If I go into battery charging system, we could really dive into the design here as well. And you could see the requirements linked. And I could open up the model hierarchy, but I could also open up the requirement story. So if someone doesn't, for instance, have a MATLAB install on their computer, they could open up this HTML and get an understanding of what they want to learn about, what you've been building out. I think a really good example out of this is whenever you're doing like continuous integration pipelines, or if you just want to share this model with someone like a manager, and they maybe don't have a MATLAB install directly on their computer, and they just want to take a quick look at what you're building out. You could send them this file, and they could be like, all right, what are you doing in the battery charging system? And you could take a look into that and say, oh yeah, that makes sense. Thanks a lot. And that's a really quick way of getting them the information they need at the time. So yeah, so that's a really good thing. And so I do see one more question in the chat. Can you speak more on the architecture view options? Yes. So there was something I left out, and I think maybe you saw this. So in the sequence diagram, near the sequence diagram, underneath the views gallery, there's a couple different views already here. These are pre-generated views that I just threw together. And so it's ways of being able to analyze your model visually in a lot of different ways. You could also export these via APIs and play with them via APIs, which just opens up a whole new can of worms and gives you a lot of power there. But you're able to do things like, now that I have my System Composer model in the background, I could view that same System Composer in a myriad of different ways, such as I just want to see where all the blocks, where the stereotype of distributed application is being used. And so if I have that, I could see, for instance, position determination system is going to be passing data to environment perception system, path construction system. But I could also see, oh, these blocks aren't connected to anything. And I think that's really powerful as well. Also, you could place this metadata on things like ports, connectors. One of my favorite things is you could start doing graph analysis and seeing how a piece of data on one port is going to be passed throughout your entire model, and you could create an entire representation of your model using that. So there's a lot of power here in terms of visualizing and analyzing your models in really interesting ways. Hopefully that answered your question. So now that we talked a little bit about report generation, a little bit about model-based system engineering, I'm going to hand it over to William. Put him on the spot now to talk a little bit more about the report generator side of the house.
Yep. Thanks, Andrew. Of
course.
And yeah, as we're waiting to sort of shift modes on that a little bit, it's interesting because and when I introduced it at the beginning, I said we're going to cover model-based systems engineering and then report generation. I must admit, I pulled a little bit wool over your eyes because we already started talking about report generation with the web view. That is report generation capabilities. And some of the things Andrew talked about are exactly the sort of things I like to talk about when I'm talking about report generator. So there are two different report generators available. A lot of my examples are gonna be within the MATLAB report generator, and then we're also going to transition to the direct components with System Composer, which also deals with the realm of Simulink report generator. So I have a quick poll for Andrew. Can you have a guess on the difference between MATLAB report generator and Simulink report generator? It's a toughie.
So hopefully I answered this correctly. I used to work with the tools a lot. So MATLAB report generator gives you a lot of helpful APIs, interfacing to address MATLAB-based workflows.
Yep.
Things like reporters, I know that word,
Yep.
where you could start parsing whether it's your results, your scripts, and start creating scripts that will actually help build reports based on that. On the Simulink side, it's going to build on top of MATLAB report generator to give you a lot more helpful APIs, just pretty much helpful APIs to write scripts based on Simulink constructs and system composer constructs.
Yeah.
Yeah.
Yeah, that was a great answer. That was honestly more, first of all, we didn't practice this, so I really appreciate Andrew on the spot. And honestly, that was more elaborate than I had even necessarily expected. I was more going through the basic, which is MATLAB report generator focuses on MATLAB workflows and Simulink on Simulink workflows. But no, your answer was great. Yeah, and as Andrew mentioned, so with this, I'm just pulling up the product page, partially because I feel like if you were like, for instance, looking and being like, how do I generate reports with MATLAB? This would probably be a pretty good place to start. So as we mentioned, we're generating reports using PDF, Word, PowerPoint, and HTML, as well as using that with different templates. So those, we're not going to get into every single workflow. Similar to Andrew, we don't unfortunately have the time, but that's the basics on the MATLAB side of the house. And similarly with Simulink, we're able to also generate reports, PDF. You'll notice a lot of common language in between because that. And then artifacts for different industry standards. So I want to talk about this for a minute because as I mentioned before, my background was in aerospace, and when I joined MathWorks, I had already kind of realized I had an affinity for understanding some of the uses of the report generator because ultimately I did a lot of work in verification and validation, and at the end of the day, if you have test results or you have requirements or you have design, you need an artifact because that is an essential part because unfortunately the FAA won't just you can't go to your plane and have the software and just say, trust me. You need to actually prove that works for obvious reasons. So that's like an essential part. And that also gets to what is the use case for the report generators. So in general, if you want to create a PDF or Word, it's certainly a great capability. But it really shines when you need to make reports continuously, or you need to make really big reports, or any sort of repeatable offense, whether it's for certification, you need to generate artifacts, you need to share with other people, similar for the web views. Anytime where that case, I think that's really where it shines. And one of the even things we mention internally occasionally is some ways the report generators are report generators because you're using these tools to generate scripts to be able to continuously generate reports. So,
Oh, I have a quick question.
Yeah.
Do you have some examples of types of reports that you would create?
So, yeah, I mean, in terms of like, do you mean like using the report generators or like?
Oh, using the report generators.
Yeah. So there's different examples that go through capabilities. I would say there's kind of a couple of different kinds of. So if I'm going into the documentation and I want to create reports, there's different. Sorry,
We're searching live.
We're searching live, so I just want to make sure I'm on the right view. And this is a great. So this is an example of if I want to look about the kinds of reports. This is a fantastic documentation page. This is the task examples. So what this does is covers the different capabilities into different reports. So let's say, for instance, I wanted to make an image-based report. So I'll give an example. Say I was one of the examples would be, say I was working on an aircraft and I wanted to have a way of capturing different graphs. Like we had a bunch of different graphs we were running a test on, I don't know, we were measuring bend in the wing, and we had a bunch of different graphs associated with that. So that would be a kind of report, and then I'd be like, okay, what output format am I looking for? We'll say it's a Word document, for instance, and then we're going to say side-by-side images. This is a little bit different example. Maybe there's also peppers and a nebula associated with this wing fluctuation. But this showcases how, on a fundamental level, to generate a report like this. And why don't we actually go through this? Because this is a transition point, because this is actually an example I wanted to mention about. So what this report, so we're going to shift slightly, though. I'm going to generate a PDF, because I realize now that the one I did, as you can see, this is live. I had almost the perfect connection, and then remembered the example I was going to show is PDF. But same basic principles apply. So we want to create a report to demonstrate different figures. So what we're going to do first is import in different information. And we're importing report.gen.dom, that's a report. And you might be asking, OK, great, what the heck is that? So the report generators, generally speaking, leverage two different APIs. They leverage the DOM and the report API. And we actually had a discussion before this on the differences behind this. Generally speaking, the DOM covers lower level objects, and the report API has higher level objects. There is also some specific nuances I won't get into today on like what exactly a DOM capability is, but in general, they're whole different kinds of reporters. And then this is, like I said, similar to how I feel like if any user is going to try and figure out, we're looking in the documentation, we're trying to figure out what's going on here. So you'll notice, even in the doc, it talks about the MATLAB report generators and those different objects. So title pages, subsections, MATLAB variable values. And even similar enough, we can take this, and we're going to look at help MATLAB report generator, and you can see, and this is one of the great things about MATLAB, and I find in general working in MATLAB, I can just go to the website, take it, and be able to leverage this. So we can see all the different kinds of capabilities in this. And this is going to be important because these are our sort of building blocks, as you will. I know I previously alluded to a reporter that builds other reporters. These are our tools. These are our abilities to generate this. And similarly, if we talk about the DOM API, I had mentioned, this is like things, lower level objects like text strings, paragraphs, images. We're going to come back to that, and tables. And this is how they create their software object. And similarly to the report API, where we are having our different capabilities. So these are our different format classes, and color, display, font size, font family. Similar objects, italics, similar things you see if you pull up a Microsoft Word document and you're like, how do I adjust this? You can have similar capabilities. And as hopefully it's starting to come together, the combination of this is the really powerful thing. When you're able to leverage both capabilities, you're able to with their powers combined, be able to work on that example. So I know that was a little bit of a side on just 2 lines, and you're like, how are we going to get through this whole thing if he goes through all lines? A lot of it will hopefully be quicker, but I really wanted to spend a little bit of time talking about this because I think it's really the fundamental building blocks for report generation. So then we're going to create a report object, and we're going to label it. It's going to be called my report, and we're going to open the object. And now you're going to notice we're going to be making page layouts, and we're going to be setting things. So similar to any sort of document you're working on, we're going to make sure it's a landscape. We're going to set the page height. We're going to set the width. We're going to set the margins associated with the page. And we're programmatically just putting in this information. So if we run it and we think, oh, I don't actually like the page width, we need to go 10 inches, you can adjust that. Similar to if you ever have, not necessarily everyone's done this, but if you've ever worked on like programmatically writing like a Word document or a report, it's very, very much that sort of workflow. And then, as we mentioned, we're going to want images. So in this case, we're using these different images, but you could imagine we have pictures of plane fluctuations. Getting back to that arrow example, we're able to get those images imported in and center them. And then we're going to close the report. and view the report. So we are going to then view this. And I did see a question in the chat talking about running things previously. I know I skipped over a little bit, but this is similar. So this is the live editor, and we're going to be able to run this section to be able to showcase this. So in the background, it's creating this, and you can see we're going to show exactly this. We have this cat's eye nebula and this Peppers example, and hopefully you can see, you know, when we have the specific images, we're able to, I'll just load it up here, probably slightly easier. So a little bit tricky. I'm a little bit used to doing this with 2 screens, but you can see the different, I'll just focus on the report for a second. You can see the images associated with it. We've got our figure, we've got our image, we've got our functional, and you can see similarly, we've got the JPEG image, we've got the cat's eye nebula, we've got this generated properties. And then this has a little bit more information within the example. If you'd like to go through, this is a shipping example and talks about different additional capabilities, but I do want to keep on moving on. So this is sort of the DOM and report API I mentioned. There is I'm not going to spend too much time on this, but similarly, we're going to, you know, Andrew, you had asked about earlier different report types. So we're going to shift to a slightly different report type is PowerPoint. Hopefully, a lot of you have the experience of needing to create a PowerPoint report for whatever reason. We just showed one earlier, so variety of use cases. And one of the things we can do with this is use the PowerPoint API similarly. So we're going to start with this report gen example. I believe I still have it pulled up. It's in the doc. So yes, help section. OK, so this is the script associated with it. So this is what it looks like in the documentation. I have, normally you could just also copy paste this into the script. I already have, as a cooking show, I have prepared something prior to the show, so I've already done that, and we'll run from there. But you can see this the scripting associated with the presentation, as well as the slides associated with it. So, you know, we're going to put in the PowerPoint API, in this case, create the title slides, create the subtitles, add in the content, and generate this. So we're gonna run this. And then, like magic, we have created our very own PowerPoint presentation. So we got this one to work a little easier. But you can see the title slide, my presentation, subtitles, create a presentation. We've got this first content slide. We've got the different font associated with this. And we've got the different first, second, and third items. So these are this line, and hopefully you can see replace objects and adding this. And it really functions the same way as the DOM and the report API. You're putting in different objects, you're combining them, and you're putting them together. But let's say, great, I generated this report, fantastic. I don't want to go back in and all do this if ever I have to make a change. So in addition to, you could obviously do that and update the script, but we also have this function which is going to load in the object and make objects. So in this case, let's say we wanted to make a little tweak here. So we're going to look at, say we need to add in a 4th item here. We're going to create a script that's going to do that. So it's going to open up the My Slides. It's going to modify the content. So we'll see an adjustment on the slide. And then we're going to add in an additional section. So we're going to run this. It's going to take in our already generated slides. So for instance, if I ran just this script and not the previous script, it would error out because the My Slides wouldn't be there. And then once we run this, if I have made the adjustment, or if I need to close there we go. You can see the presentation program and the modified content slide within that 4th updated item. So this kind of demonstrating, and similarly with the report and DOM API, being able to take your objects, update them, being able to do this. So I think we have a question. Can the report generator look at a designated file directory and pick up changes automatically? So I think, Unfortunately, I'm going to be a little, this is a little, admittedly, this is a little outside my area just because this kind of gets in with, I think, revision control is maybe what this question's about.
Yeah, I could address a little bit more about this one.
Yeah.
So, yeah, can the report generator look at a designated file or directory and pick up changes automatically? And this is actually a really interesting question. When you're talking about the lifecycle management of your project, of the design of your system, how do you start to automate a lot of what, William's showing here? You don't want to write this every single time for a new artifact. And something we'll talk about there is you could build out like templates and hand them off to everyone. You could also just pull our examples and start working those. But this specifically, so you could just take this script, you could plug it into some sort of mechanism, that mechanism being maybe like a continuous integration pipeline. I know I've mentioned that before without necessarily defining it. But it's just some sort of mechanism that's going to run scripts for you, whether it's on like a time setting, like every night something's going to happen, so that in the morning, when you come into the office and someone's made changes, it's automatically going to build these reports for you. You could do it nightly. You could do it, for instance, if you're on a team of people and one person has made changes, whenever they want to submit those changes to the rest of the team's remote repository, that could kick off the action that's going to call these scripts, that's going to look in those directories and see, are there any changes left? And you could actually build out the reports from there. Speaking of, MATLAB and MathWorks, MathWorks and MATLAB Simulink, System Composer, all have capabilities to plug in directly with change management tools like Git and SVN. So you could use those tools under the hood and start doing change management processes. You could do revision control. You could build out reports exactly based off of that information. So, you don't have to, something I do like to emphasize is you don't build these scripts every single time you want to generate a report. You build them once, you automate it, you have them build out automatically on their own, and that way you just get the artifacts at the tail end. A lot of the work is already going to be pre-built for you because there are a lot of great examples that William and his team have built for you guys, so it's almost for free.
Yeah, no, for sure. Yeah, it's similar to what I was discussing earlier, the reporter that builds reports.
Yep.
So now we've got one last example, and I was, if we were, you might have said, which you may be thinking, maybe not, maybe I'm speculating on viewers, but you might have been, this is great, William, you just showed a bunch of very simple examples, and I don't know how that connects necessarily as, we talked about the web view, but we can talk about this. So Andrew's example, we're bringing it all together now. This is the electric vehicle architecture example. So we are going to take all of the concepts of the report generation and leverage that with all of the systems engineering work that Andrew showed and show how this report works. So similarly, we're going to close the allocation files. We're going to generate this report generator class. So this actually has some helper functionality, which we won't necessarily fully dive into today, but there's more under the hood to make this easier, basically, for this particular example. So then what you'll see is we'll take in our logical architecture. We'll define report properties. There's actually two different versions of this. There's one for a full architecture report, as well as just the logical architecture. We're only going to do the latter because time-wise, I mean, honestly, we're not even going to get through the full logical architecture report. But this showcases different scenarios associated with this, traceability tables, elements, allocation, and then we're different interfaces associated with this. And then we are taking all of this system composer information that Andrew talked about. We're taking the front page and we're appending this all to one singular report. And then we're generating it. So, and I've used this term before. I prepared this beforehand because this does take a little bit to run. But you can see, I'm not lying, this was, I think, yesterday? 2 days ago. Can remember a bunch of the stuff, but not remember day of the week. But anyway, electrical vehicle logical architecture report. So this is kind of the, I would say, expansion of the capabilities. So we have an introduction, operational scenarios, and then you can see the, sorry, we can get into the logical architecture. So You may remember these from this, and this is not too dissimilar from the web view capabilities that Andrew showed earlier. We're able to dive into different sections. We're able to live connect. We're able to look at different interfaces and ports associated with it. We're able to dive into the different elements, look at the sensory inputs, and similarly, it's similar to the web view. It's just at the PDF. So you can just, as you would share any PDFs, you're able to demonstrate the different information, and we can also add in, talking about the different components. So this can add in, similar to I think what Andrew was talking about with the functional and informational. We have this additional little paragraph talking about the different main areas, talking about the different drive management systems. So if you didn't necessarily have the benefit of Andrew going over that full example with you, would be able to cover information. And you can also see the logical architecture, this battery charging system within the center thing. I think you could access this. Anything else should be covering on the report here?
I think it's important to show we saw the sequence diagram quickly.
Yeah.
I think the important thing is that these reports just can be used in a variety of different ways, whether it's just for helping other people understand, for you to artifact and keep them around forever. These reports will be around for 50 years. But yeah, it makes it really easy just to share information, whether they have to be formally specified, right? Our tools do have qualification capabilities in terms of DO 178 type workflows. So there's a lot of goodness baked into these tools.
Yeah, I might very briefly. I was wondering if.
Yeah, let's take a look at that.
Yeah, I was going to say. I think there might be something in the full architecture report. There's 188 pages of this, so I'm not. But
which is a benefit, because if you had to write it manually, that's 188 pages of time spending building out reports. Or you could just automatically generate them.
Sorry, is there anything specific you want to?
I think we could take a look at the functions. You could see, I think, very early on in the diagram, we saw that functional architecture, which we didn't cover in System Composer. It's just specifying all the different functions we need. And later on, there's also physical architecture. And I think in this report is actually included, we run an analysis using MATLAB over that to get some sizing of our initial components inside of our electric vehicle
you can
component.
See the physical architecture section.
Yeah, that's our physical architecture. Where we have a lot more in-depth example. If we stepped into electromechanical system.
That's the center one?
Yeah.
Yep.
Yeah. You can see how the physical architecture is actually composed. Yeah, we didn't really jump too much into that, but it's also helpful to see the inputs and outputs. You could create things like ICDs, interface control documents here as well. I think something really important is the system design descriptions coming out of the report generator are default. The way I've always explained it and the way it was explained to me is, let's say Simulink, MATLAB absolutely never works on your computer again. If you have that system design description, you could regenerate your Simulink models, your System Composer models, all the artifacts, because everything is going to be baked into that one report, and that could be automatically generated from Simulink and System Composer as well. So
yeah, and just to add to that system STD, I think one of the really powerful things is you can kind of get into that in the weeds of that as much as you want. So you can just auto-generate it, use the default capabilities, and then fantastic. Or, which you should be able to at least hopefully get a little start on, because we went over some of the customization stuff, you can use the different APIs and do custom reports and being able to dive into that. So you can start just using STD. That's fantastic. STD is a great tool from the report generator's perspective, but you're like, hey, I have a custom corporate template we want to incorporate with this, or is there specific information that is associated with it, and that's able to be involved with that. So.
Yeah, and so we do see a question in the chat: are System Composer and/or Report Generator a separate toolbox that would need to be licensed? And the answer is yes. So System Composer exists by itself. It's built on top of Simulink. So in order to use System Composer, actually right now you need to use Simulink, or you need to have a Simulink license and have it installed. Likewise for I'll let you answer the report generator side.
Yeah, so the report generator answer is actually a little bit, it's complicated.
Yeah.
The reason is as we were sort of alluding to, certain other products are able to leverage report generator and generate like prefabricated standard reports. Sometimes, and I'm not going to go into the full thing because it's a very involved question, it will be, you can just generate the standard report without the use of a report generator license. Generally speaking, for customization, you're going to need a report generator license. There is a bunch of more nuances, and if you have specific questions, please reach out. But generally speaking, for a lot of report generator capabilities, occasionally you will see instances where you're able to generate standard reports using different products depending on what they're leveraged. But usually for customization, it typically requires the report generator license. I think that's concise and detailed enough as we're going to get here.
Reach out to MathWorks if you have any
Yeah,
questions.
I'm happy to reach your specifics because it gets involved. Yep. So. All right.
Also look at MATLAB Central. There's always a lot of great community hosted questions, and we try to get to those as often as possible. Yeah. Feel free to ask any more questions. Yeah, I was going to say, speaking of questions, we're approaching the end of our time. I know we, so if you have anything else, this is probably your opportunity, last call as it were, for questions. But so. One thing I'd like to just go over, so I had mentioned a little bit, so if you want to know more and want a general thing, I highly recommend the MATLAB and report generator pages. As well as System Composer. As
well as System Composer. I was going to get to those, but yeah, I was going to start with the MATLAB and report generator pages. They have different sections, links to the documentation, as well as examples, technical articles, videos, various information, similarly to Simulink report generator. And then if we're going to go right on to System Composer, Andrew, if there's particular things you'd like to highlight here.
I think some important things here is System Composer is both for system architecting and software architecting. Mm-hmm. On the software side, if you are a little bit more focused on the software architecting side, we have generic software architecture capabilities. If you're familiar with service-oriented architectures, those capabilities work with what we were discussing about today, as well as if you're doing AutoSAR or some more industry-specific software architecting. But yeah, please take a look at this page. Feel free to look at a lot of the examples, the user stories, the videos. We are trying to get a lot more help out there in terms of getting the people educated about system engineering and how to do that with the MathWorks tools. But
yeah, I think that covers it. So hopefully we were able to give you some insight under the hood of how to use these different tools. I thought it was fifth, but we'll go look over the recording later and figure it out. But thank you so much for joining. Thank you, Andrew, for being here. I thought it was a dive, hopefully learning how to do system engineering and report generation within the tools. As we've mentioned before, feel free to reach out to MathWorks with any questions. And I think on that note, I think we're calling it a day. Any last thoughts, Andrew? Or?
I like it. Thanks for joining us.
Yeah, thank you so much, everyone, and have a great rest of your day. So, cheers.